Hello, this is Richard Collins, and I'm going to try to see if I can explain what I'm trying to do uh, for the internet as a whole. I've been at this for about 22 years now, studying the internet, seeing if it can be uh, uh, simplified. Uh, and what that's meant is actually having to look at how computers are used fairly generally. And in recent years, more and more sensors. So let me see if I can do it. I'll explain this in just a moment. First, I want to show you this box here. And let me see, that's this one here. Okay, this I was doing, this is about 5, 6 years old. And I was trying to explain to somebody, you know, roughly what was going on at that time. Now, I've spent a lot of time with global networks, gravimeters, seismometers, satellites, multispectral sensors of all kinds, GPS, just detectors generally. So these are all different names that people give to different things that are going on. At that time, internet cameras were just really beginning, to come in, and phone cameras. YouTube was not even that old, and you know, exchanging content in a different formats was coming up. So all I've my background is physics, so I've actually dealt with data from almost all of these. So I think that's kind of my bias is, as a mathematical statistician, I want to use this information, tie it to models of whatever people are trying to do. If you're doing MRI, well, you want to look, 3D MRI, that you can stick it in your pocket, and there are people working on things like that. So I've tried to trace down all of the communities that are doing all these different things. So anyway, now in here, what I was trying to get a clear picture, of the current operating system. So whether it's Windows or Linux or Arduino or whatever else, ultimately, their concept, just to get the thing working for a few people, is okay. We have a disk, we have a mouse, we have a screen, we have touch sensors of various sorts, keyboard, we have memory. And I didn't stick one in for the sense of communication. We have network. We talk to each other people. Now, what they did was they put in a core, what they call an operating system, and then they basically built their own drivers for everything, or they allowed people who made the devices to bring drivers into their operating system. And whether it's Windows or Linux or Arduino or embedded or whatever you want to call it, this is roughly there. And they put a boundary around it, and generally they try to market this as a coherent whole. The thing is what's going on now with these are all devices like those ones that I had from that table. So an MRI, a car, an airplane, a starship, a machine tool, whatever you might have, a device which basically communicates. It's got data that needs to get there. So what are we doing when we use an operating system? Well, we have a screen we look at, and we have a keyboard you can talk to. So you're communicating with some device out there, and this is kind of the way we started. So, but could we change a little bit? Basically, what I'm looking at now, the smaller systems. Here I got a whole of various sizes. The intelligence in here, instead of operating system. What I'm now using is a term what I call intelligent algorithms. And yes, that is a deliberate flip on AI. I took my first graduate course on in artificial intelligence over 50 years ago now. And, I was a sophomore in college, and they let me take, this graduate artificial intelligence, and I felt it was incomplete. So anyway, that's personal story, but now I say intelligent algorithm. So what am I talking about? A courteous, communicative, easy to understand and easy to instruct system, which happens to be written down in hopefully in a simple language, and which makes some device intelligent. Now, our cell phones, pretty much everything that we have now is moving in this direction. And all these things like, if this is an MRI, or, this is a, machine tool, or if this is a 3D printer, 3D scanner. I do a lot. My physics interest was in gravitational radiation and detection. So I'll put in gravimeter, and things of that nature. So, all right. So what am I recommending here for your camera? Okay, that's and actually think about it right now. The OSs that are out there, Windows does not do camera. Okay, it did a token. It says if you want to come in here and try to make it work, we'll sort of let it in. But their drivers suck. Pardon my French, but it's not well supported. And so, if you have a camera out here, sorry. All right, one more time. Camera. If you have a camera out here, how many kinds of cameras are there? And there's no universal driver in Windows, okay, for every camera. And I think, Windows, we should let every flower bloom, and anybody can do their own thing, and we'll just put a ring around it and call it Windows, and we'll let you make your own drivers and everything else. And the problem is that might work, when every system is simple. But if you're going to apply this for industrial or scientific or any kind of technical application, which is the way the world's going. I mean, even our simplest cameras are getting smarter and smarter. So I'm wandering here. Let me see if I can let's see what else. I try to prepare stuff. Okay, so all right, so. Okay, these different shaped blue boxes are all intended to be machines running some OS. So here's some Apple OS machines, and here's some Windows machines and Linux. I made them different shapes to do it. But look, when I've used and tried all kinds of like Arduinos and embedded systems, and and actually even down to the GPUs and the MCUs and all the little things where they're shoving the processor down right next to the sensor. In fact, all of these like if you got a machine tool, it's got embedded stuff inside there. And the problem is they all speak different languages. So what I'm thinking of, okay, what I'm suggesting, let me go down to quite specifically here, okay, and that's a brush. I'm saying, where's the camera? Okay, I'm saying, you guys, if you go in there and make your own server, literally running as a service inside of Windows or inside of Linux, or I could, let's see, I'll just say, here, I'll give you a server name there, and then, or inside Apple or Raspberry Pi or some Arduino. Basically you write an interface to your specific cameras, right? And then and that should be it, right? And the thing is, okay, I can try to help you like write a universal language so that all the other, now if you get the industry to do it, they're going to want it to fit their own cameras. But if you do it for the internet as a whole, things might change a little bit. Now, all right, I just grabbed a huge lot of stuff right there right now, so I'm trying to think of all the consequences of that. Okay, let's get back to, so you have a server talking to a camera. Now, how do you get to it? It happens to be running in Windows, right? Okay, so you made a Windows-based, compiled. It's like a C++ program, so it's compiled. It's efficient. It talks and squeezes everything out of that camera you can imagine. Now, okay, all right. Now, let's see. Okay. But you want to talk to everybody. Okay, now let me see if I can get there. I'll do this shape here. Okay, so I've got over here, I've got a browser, right? And let me make the browser a different color. Okay, so here's a browser, and let me call it browser. And I want this lettering to be that way. Well, here's the thing. There's a whole bunch of browsers, and everybody's got to support everything. This is an n squared problem. You have, or it's n times m. You have this many different, programming environments, and you have that many instruments. So it's going to be n times m. You have to take care of every pair of possible connections. But if you come down and say no, we'll do it. So every, the browser can talk to anything. Okay. What is the browser? It's a human interface. So a human is talking and wants to run the starship. Says computer, do this, or a machine tool, do that. Well, we don't have voice for everything yet. And we have so many human languages and speech variations that I'll set that aside for now. So right now, somebody types into, some kind of interface, and they say, car do this, microphone do this, robot do that. All of these different things. Pardon me. So okay, we got a browser, and I'm just thinking of, okay. Somebody comes and says, look, I really want my, let me stick one in here. I need, okay, I need sorry, this thing here. I got black, so this is drone. I've spent a lot of time looking at drones recently for some reason. Okay, so, you have a drone and you want to tell it to do something. Well, you really need to be able to communicate easily with it. Well, if you write a server, okay, let me use this guy here. Okay, if you write a server, that's controlled by, oh, here, let's put it next. So, this is a browser running inside some operating system. It's just a server itself. And then you have another server that can handle camera. So, oh, this is so difficult. Okay, all right. How can I explain? All right. The thing that helps me sort this out is to think of the community of people involved. Okay, there's only a finite number of people, and there's nearly an infinite number of these things. So the problem gets simpler if you think of the people involved. Okay, Apple Computer. It has so many thousands or tens of thousands of employees. It has investors and other people. And it's and the users, right? Okay, so all of those people should be working together, right? And the thing is they don't own all the cameras in the world. Okay, there are, and yet they probably all would like to talk to any camera that that exists, right? For whatever reason, oh, today, I have to have this need for it, and you know, uh, the people here, they're in universities, they're in industries, they're all over the place doing things for society as a whole, and they need tools. What we don't need is, okay, I guess I'm trying to simplify the thing. I don't know if I have or not. So, all right, let me try it. Let's try to see if we can do this. Let's take up this. So here's a server that runs inside an operating system, okay, and it's dedicated. So you have a camera server, right? Okay, let's put that in. So this is a camera server, and this is particularly one that speaks to a specific camera, right? Okay, so this is specific camera there. So it's kind of like it's kind of like a device driver, but instead of speaking OS language and acting as a device driver inside a particular operating system, it speaks HTTP JavaScript. Now, why did I do that? The reason is, yes, there are specialized situations. There's always going to be. But for global users, everyday users, that is the common denominator that they have at the moment. Okay. Will it evolve? Absolutely. Nothing's sitting still. But for the moment, for the next, short time in human existence, there's a large number of people and devices that can speak that way. The internet is HTTP. Okay, sorry I hit that. You get what I'm saying? That is the core. The an Ethernet packet switching network that will survive a nuclear holocaust was, I think, the original intention. Now, the HTML side of it. Okay, let's put one of those in there. The HTML side of it is different. That's a human interface. Okay, so let me just move that over here. What is this? It's a layout language. Okay, and that depends on the devices and things you're doing. There's not a voice HTML. There's not a robot control HTML. If you try to cram it into, HTML pages on the web, it generally doesn't work. Believe me, I've tried to look at the entire internet, all the internals, all the instances of things out there, all the variations of what people have tried, and yes, I've only spent 22 years at it, but I think I have a rough idea of what's going on. And generally, this needs to be rewritten. I'm trying to do that. I'm trying to change the layout language so that you basically what is that? Most of this stuff is I don't have one here, do I need a screen. That's on the other one. Basically, most of this relates to the screen. Okay, it's the right. That's a good chunk of HTML out there. Now, are people trying to put data in there? So I do a lot with scientific models, models of all kinds, accounting systems, and databases and things. That's what I did in about 20 years of my life, was doing those kind of global. Anyway, so all right, now so the camera survey. You have a specific camera. We're talking about, in this case, we're talking about that one 3D camera, and we're trying to get the most out of it. And there are, okay, let me guess, how many people in the world might want to deal with that? Well, I have a way to check. Let's see. Let's go. I'm going to hit the save button because I want to be able to come back to that. And I need a browser. Okay, so, I was looking at how many high school students are there in the world. Because when I was in high school, I worked on random neural nets. I worked on chaotic sequences. I designed computers, and there's all kinds of things that I could do that, if I could go back more than 50 years. All right, so what was I saying? All right, RealSense. That's the particular 3D camera we were looking at. Okay, so 1.8 million entry points. When I do a search on Google, what I find is this number I treat it as the number of entry points. Okay, and what I mean by that is, first of all, from the website side, if those entry points all need to be open and welcoming to anyone interested in this, right? And like if you have a large site and they don't treat the whole external world as a single entity, then it becomes chaotic. So okay, all right, it's so hard because I'm working on so many facets of this at once. Let's go here. So roughly, it depends. It varies. Let's say this is a couple of 100,000 people out there who are involved in this in some degree. Whether they're buying the products and not talking about it, there's a bunch of those. Now, this market hasn't really gone very far, and most of it is because they're not making tools for everyday users. This is not a tool for everyday user. This is it's an experiment to see if there's a market out there. What they didn't do was to go look directly at what people are trying to do with this and then fill in that. I apologize to all the people who are going in there. Let's see. All right, let's do something more. Camera. 3. This is the real universe of this. Okay, 3.93. Now, can every camera look at 3D yet? No. Will there be? Probably. Okay. Turn the camera on. Okay. All of the cameras should be able to be run as remote webcams, either locally for your own purpose or there. What does that mean? It means that the camera runs off of a server. Where does the server run on? It runs in some operating system. But if the webcam, let's see this. All right, let me try it one more time. Let's see. Let's go to here. Okay, I'm not sure. Okay. All right, so you treat. Okay, you and I, in a sense, we don't really know what's going on inside of any of the operating systems. They sort of do their job, but you say, look, OS, this big lump of software there, help me with my camera, and then no, it's not going to happen. So you kind of almost have to say, well, look, okay, I've got I've got my camera here. There's a community. There's that global community of 3.93 billion, entry points on the web that talk about camera. That means pretty much every internet user on the planet has or thinks about or works with or uses cameras. And the thing is every camera speaks a different language. Every one. Think of the waste to human society that you have because they are all doing their own thing. Okay. Now, to some degree, the same thing is true of microphone. The same thing is true of display. I'm not talking about the hardware interfaces, which are also, everybody's fighting for market share, and they're all doing their own thing. But a display language should be universal, a camera language universal, and a microphone universal. And to some degree, they're all just sensors. There should be a universal sensor language, SENSOS, sensor. Okay. Now, the thing is sensors now are not just that, okay? They're also controllers, right? That is, you have to, they're, okay. Now I know why it was so hard. I was trying to write in English text, in a text editor that had no ability to include images. So, a lot of what I want to express is visual. And so, like I would like to have cameras. I'll just tell my personal interest, okay? I would like to have cameras that I can use to watch the ocean, watch flames, watch water falling, watch plasmas, watch astrophysical events. Okay, basically it's a 2D array to me. Okay, it's pixels coming to me right now. The way they're coming to me is in frames, rigid frames of fixed number of pixels at a certain rate. Well, I learned about this stuff called region of interest, and I am desperately wanting to find some cameras that allow me. I found some. I kind of know what they're doing in terms of how do I program those. But okay, region of interest. Okay, so what is this, and what am I trying to do? Okay, it's okay. You, if you have let's just do. This is freehand right here. Okay, say I have a pixel array in here, and it's coming in at so many frames a second, right? Now, this gives me a fixed band. There's a fixed bandwidth for sending this to me, and that sets the amount of information I can get. What I want to do is to say, go in here and give me a little region of thing. I'm talking about 10 by 10, or 10. So if this is basically what I want to look at are small arrays that can go at a million regions per second, 10 to the 6, or actually I have my real requirement is 10 to the 9th regions per second. So, all right. Well, that's my personal aside. So and you can guess that I've see you can see my cursor, but I can't. Let's see. Let me get something where I can see it. Oh, there it is. Okay, there. This thing here, where I've been trying to look at all the uses of here. Okay, depth sensors. There are scientific models for the oceans, and there are many 3D techniques that are evolving. Okay, length sensors. what they call super resolution techniques are getting, basically they're saying we can do better. We don't have to have fixed sinusoidal wave, visions of the world. We can go in and look at the details of the exact timing and the intensities and the depth and character and structure and internal, organic understanding of the thing. It's hard to say that. That's the one. Okay, high-speed cameras, and basically with our limited bandwidth right now, what we're talking about is like to get to the millions of regions per second. There. Now, if you can pop the region around, you can follow something, right? You can go in and say, look, I'll stack my regions, just like in astrophysics, just like you use a stacking algorithm to track a star. You could do the same thing. You use a broad set of pixels for the whole thing, for a wide area of view, just like the human eye does. And then you have basically you use the high-speed information gathering to collect that much more data. So you have like, USB 3 type capacity, 100 megabytes per second or something like that. Then you collect it on a few pixels, jiggle them around a little bit. You use an IMU to keep track of what you're, exactly what in the real world you're looking at, and then you can use that to, for super resolution to go in there and build a better picture. Even if all you did was to go in and zoom in on that and just collect more by stacking, instead of 30 frames a second or 200 frames a second or 1,000 frames a second, you go to 1 million regions per second, and then you stack those down, down to a mere 1,000 or so. But you could get more out of it. Now, I know that's not a well understood area. There are going to be somebody on the planet. There's going to be somebody who, that's old hat. I can do that every day. Well, for me, at my level of still trying to, struggle to learn all these things, I have to go in and try the data. And when I go to look at all these sensors, I'm pretty much in a situation where I have to beg. I had to go and spend a year or so to learn how to read the gravimeter data, to do the orbital, basically what did I had to go to NASA Jet Propulsion Labs, their Chebyshev polynomials, and learn how to calculate in basically on my desktop the exact positions of the sun, moon, and earth, and calculate the tidal gravity for it, and then I could use that to calibrate the whole network, right? And then when I went to the seismometers to do basically the same thing, I had to go in and read. God, they have all kinds of different instruments, and they all seem, they all have different responses to seismic waves and to gravity, and so to get them to work as 3-axis gravimeters was really hard. I worked a couple of times, one for an agency that wanted to track everything in orbit, and one for NASA where we're using satellite positions and data from satellites to refine the gravity field of the Earth to high resolution. So when I worked on, I'm just thinking of I'm wandering here. Multispectral sensors I use for tracking vegetation in Africa to set up an early warning system for famine. Okay, so the GPS I've been looking at in recent years, and you can use the carrier wave dual frequency to look at the electron density in the ionosphere, and then you can also use it from the ground up to look at variations which indicate weather, basically meteorology, and in large regions, you know that ties into climate models. Okay, so all of these, I've spent a good chunk of my time looking at these things. I've spent a lot of time on microphones. I think they're really wonderful. I don't have the pieces don't stick together. Okay, I want to use a computer to look at data from a microscope. I can't get to it for the most part. If all those crazy cameras, they're, somebody gets something working, and then they find, oh, we can sell this, and they make a lot of money, and then they never, it never develops beyond a fairly low level, okay, unless you're willing to pay. Now, I can't afford all that. A lot of people can't. I think, okay, I'll go back. In the fourth grade, I learned what spectroscopy was about, and that got me interested in chemistry, and that's been a lifetime interest of mine. And in high school, I got interested in random neural nets, the brain and how it worked, but then computer. So I went out and interviewed my local companies to ask them what they're using computers for. And I met a guy who was a designer and engineer for the 370 series, the IBM 370 series. He taught me about microcode, and basically it said, you can keep going and programming all the way down, whether you write it as what today you might call an FPGA, or a neural net type of, expression, or, anyway. So, all right, so I don't know if this is making any sense. I'm trying to do a brain dump on, on a life. I'm 71 years old, okay, and I started, over 50 years ago working with computers, and also because my scientific interest, pretty much everything. Let me show you some lasers. This just caught my eye. Okay, what are we faced with now on the internet? I'm just going to talk. If you want to listen or not, you can stop or do it. Let's see. Okay, so I need a browser, and let's see. So that's just the singular of it, laser. Yeah. Okay, so there's only a billion entry points on the web. Well, is this serving you well to go to a site that's supposed to be able to scan and index the entire web, and you say laser, and they give you back, well, they say there are that many results, but then you get 100. I mean, I don't know how many. Maybe it gets 10, and maybe 100. Okay, so, and then they say, sorry, that's it. That's all you get. They'll send you to Wikipedia where somebody else has written about it, and they say, well, that's all there is. You want an overview of it, you have to go to Wikipedia, where part-time people go in there and write things, and then they rewrite them, and they rewrite them, and they rewrite them, and they rewrite them. It's not stable at all. Okay, so laser. How many people on the planet are affected by lasers now? Quite a few. I mean, even down at the level of LED indicators or LED displays, or my latest 3D machine tool that will go in and cut things using a laser. So it's pretty pervasive. But is Google giving you a summary of all the uses of it? Are they tracking the groups that are doing the research? Are they showing you all the equations and methods and models nicely laid out as actual tools so you can understand there? Okay, if you go look at this, okay, 92 million laser principle. Let's put it in quotes. Okay, 21,000 laser principles. So look, I'm supposed to go in and listen to 21,000 copies of the same thing. I think that's a disservice to the internet. That if there, okay, let's say there were, that these were like, individual articles, that many authors who wrote in, use that term. It's not going to be quite that, because this is not sorted out very well. But say there were that many people. Are they working together to make the simplest, most concise, and complete, lossless? Okay. The problem is somebody goes and writes a review article on laser principles. Let's do the plural. Laser principle, 24,000. Okay. So they're going to write on laser principles, and then they what do? You write a book on laser principles, and you read 50, 100, books, maybe 2,000 or 3,000 papers, and you say, oh, I'm on top of it. Well, no, because there's so much going on, and there's a huge community out there that's working. So this is my main thrust with the Internet Foundation, is to understand global communities around every single thing that you might search on. If it gives you more than a few dozen results, then it's probably a global community. Solar. This is one. Solar system colonization. Now that's okay. What's going to happen is there's people say groups of words so much. I can't do it anyway. Let's try that. 666,000 entry points out there. Now, I generally roughly divide by 5 to get the number of authors. Is that right? Google could tell me. Okay, they could actually identify the organizations and say, look, here's a list of the organizations that are doing this, and here's what their contribution is in some sense. Okay. If you're going into a profession, you want to be an electrical engineer, you want to be an optometrist, or you want to be, you want to make mud pies for a living. Well, you're going to find out who's working on it, what's already known about it, what are the tools, what are the methods, what are the models and quantitative methods for that. And all of them are the same. You need to find those basic things about any topic. So when I've gone through about roughly, I can't keep count of them exactly, about 15,000 of these kinds of things in depth. I do these things. So like if I'm looking at electric power transients the other day, okay, well, I go through and I read what are people talking about, who are the people, how big is it, what are their issues, so on. You can, a human can do a pretty good job. I mean, you need to do it all the time to get good at it, but you can go in and get a pretty good sense of what's going on, who's there. Can you become a professional? No, but you can get a pretty good sense in a fairly short time. Now, let's see, RGCam. Oh, that's just a little piece. I threw this in here. This is the last 4 or 5 months of work. So, okay, these are some of the topics that I've gone through. Now, some are big, some are little. It depends on how. Let's see. Oh, that one should be much bigger. Oh, okay. Yeah. Noise cuts across everything, and the methods for noise cover everything. So I study that a lot. Anyway, so all right. So could Google do a better job? Yeah, much better. Right now, what their results are, we give you this. We tell you that's how many are out there, but we won't show them to you. They don't summarize. They don't allow. For instance, I can't say, give me a random sample of 100. You're only going to serve me 100. Look, you're saying all that's out there. So it's kind of like saying, oh yeah, there's food over there, but you can't have any, or you can only have a spoonful, right? So, and look, all they say is, look, other people said this, other people know this, and so they try to, and that's why they're not giving Wikipedia credit, authors credit specifically. Okay, certain people worked on every article on Wikipedia. You can go look and see exactly what each one of them did, and they're not mentioned in here. So I don't think it's not enough to say, oh, it's on the web, oh, it's on Wikipedia. Well, who worked on that? Who contributed to it? If you refer to an article and didn't mention the authors, or referred to what was in an article, you would call it plagiarism. You say, oh, I just copied this here. So, sorry. I don't know if these are relevant or interesting at all, but it has to do with, you want to do so. So, I was trying to do region of interest camera. Unfortunately, the names also, you can't go image sensor or something. These talk about like displaying a region of interest, and they tend to be slow display rates and things like that. What I'm looking for is, the highest speed ones. And again, there's 100 ways to say that. So, okay. So there's about almost a couple of million of these, and the techniques are in there. So this, I'd like to be able to take time and just do a mere 1.8 million pages of stuff and summarize it. Okay, that is some of what. Okay, I try it myself. I say, okay, let me spend 8 or 10 hours or 2 or 3 days and just do this one topic. And so I do that. And then I go and do another one. Then I do another one. And I do another one. And, 18 hours a day, 7 days a week for 22 years. That's what I've been doing, is going through these topics, or what I call global communities. So there are people, okay, this specific result, okay, these, if I had all of Google's results at 1.85 million of those results, give them to me. Give me that list, and I'll write parsers. I'll scan this stuff. I'll put it in a table and sort and filter it. I'll look for repetitions and common themes. There's a huge lot of text processing tools that are out there that allow someone like me to go in there and understand what's going on there. Now, I tried all of these. I did this. So the thing is all of these people are doing their own thing. Okay, everybody says, well, I'm only concerned what's inside my organization. I'm only concerned with making more money. Now, do they don't actually look. Some of them don't even. Okay, I don't want to complain too much. I just see how hard it is to do almost anything. I mean, something that I can conceive of in a few seconds, and then I go and find out that it is possible, and then I can't do that. Okay, I want to use these cameras. I was willing to spend a few $1,000s just to have one where the data comes out. But the more expensive the camera, the more elaborate and confusing and messy the development environment. Okay, they're going all over the place. They're trying all kinds of stuff. Just give me the data from it. Don't make me slave and work. And I don't want to invest a year to become an expert on the internals of your development environment. I don't want to join a community to learn yet another arcane language that you made up for your specific camera that doesn't work with any other camera in the world. So let's see. Caveat here, I happen to pause looking at this stuff. I'm not talking about any of the people here specifically, okay? But generally, there's some wonderful work going on, okay? If you go in there and if you read some of these papers, I read a lot of them, okay? Okay, Stemmer, they're coming. It's not an ad. Let's see. Okay, again, I've chosen totally at random what came up. Okay, this is a PDF. This is not a scientific paper, but it's got this long set of here, 100,000 frames per second. That's the kind of thing I'm talking about. Okay, the 500. Okay, so 12. You can do the numbers. 1280 times 1024 times 500 frames a second. You just do the math, and you come up with how big a region can I get for for the same bandwidth at 100,000 frames per second. And presumably, even though the max frame rate comes because of the triggering, the response of the sensors and all. Now I have a couple of problems in noise, okay, where if I could use that same sensor and run it much faster, okay, because I use statistical methods to process the data, and I don't need a human to see it. That's my own problem. But now, okay, these things here, what would it take? Okay, if all right, let me go here. I'm not sure. All right, so. I don't know why that one ended up so small. Okay, so so I have a high frame rate camera. Okay, so somebody makes. I've been using this green one. Okay, someone makes a camera, right? And then, oops, sorry, I wanted to leave it green, and then I have to click here. Okay, so here's my operating system, and here's my. Come on, stay operating. Sorry, I'm so clumsy here. So that's my operating system, and now I need a black server. Okay, so in whatever operating system, there's a server, and there's my camera. And so what's going on? Okay, so presumably they're talking to each other. And okay, look, there's a local processor here. Okay, so. Sorry, wrong one. There. This is so clumsy. Okay. All right, so my camera has a processor and an intelligent algorithm. Okay, I'll stick that one in. So, yeah, intelligent algorithm. It means it's smart. And over here is an intelligent algorithm, and they can talk to each other. So. So you learn enough to run a server in Windows or Linux or one or the other one. And then those core speak IA language, okay? They're just one language. And now I've decided, or determined more, I guess, more by find out what works. Now, did I have to go through hundreds of thousands of variations? Yeah. It's that confusing and that many. You saw all those boxes of the sensors in there. Every one of those is a unique environment, and they all interact pairwise. So it's not like 1,000 sensors; it's 1,000 squared sensors and processors. Okay. Anyway, so let's see. Okay. So here's my operating system. There's my device or sensor. It has smarts in there. And this is we can be a little bit more specific. Inside there, wrong one. I was trying to do that in black. And inside there, click there, and let's make it that one. And I'll do this color, inside here is an analog sensor. Okay, it can be an antenna, it can be an inductor, it can be a resistor, it can be a a surface wave in a nano device. It can be a magnetic resonance state transition sensor. It can be, I can't just go in there and grab all the names because I'm talking this language. When I try to go, I have to load an entire new language to go talk about, nano and pico and femto processes. Okay, but it's huge what we can do there, and so basically there's an analog sensor of some sort. It can be I'm trying to encourage the MEMS gravimeter designers to make them sensitive enough to do global gravitational imaging. Okay, and it's exactly the same thing. There's a wrapper for a device they call a sensor. It has an analog component. It can be like in the software-defined radios. It can be an antenna. It can be a thermometer. Whatever. It talks to, basically what are there? There's amplifiers and ADCs, analog digital converters. And then there's a local processor. And let's see, I better change. Oh, I did it again. That was going to be that color. I need another box. And then here is going to be memory. Okay, so that is, I'll just leave it in red. I don't care. So, memory. So you need fast local memory to go in and do something with it, and that includes the algorithm itself. Okay, and let's just do this. So what I would like to do, okay, I go in there and I take the data from a sensor. Okay, so this is just a sensor. It sends me data. It comes over here, and eventually I get it onto, onto the disk, right? And then I can do my analysis and statistics and models and compression algorithms so that I can say share it globally. So there's, then I can go out there and talk to the rest of the world in that. Now, so this is my desktop, a human thing, a development environment that I have, and I need, I want to talk to all these devices. Not just one, I want to talk to 1 million of them. There's probably at least 1 million different kinds out there right now. All the different kinds of thermometers, all the different types of infrared spectrometers, all the different types of laser scanning techniques. It's huge. Not to count the billions of cameras, individual cameras, and then the many types of them. So, but ultimately, it all comes down to this basic structure: some type of analog sensor, some type of, let's see, how many colors can I, I don't want to do that. I want to go to, let's put a little box in here. This is supposed to be ADC, amplifier ADC stage. Okay, analog ADC, something that runs intelligent algorithms, access to the algorithms themselves, access to local memory to store things quickly. This is what they call latency. We're talking about fast, take it in there and grab it. The Large Hadron Collider is a giant sensor. Okay, that is the Large Hadron Collider. It has algorithms, filtering algorithms, based on algorithms that they've stored there, and then the massive amount of memory. And they're going in there in real time and deciding what's useful to everybody else. Well, they throw out all the stuff that I think is good, much of the noise and much of the low energy stuff. There are global communities that could use that, and they aren't sharing. They only care about what they're. I'm sorry, I'm mad at them. So, all right, it's back to here. So a camera, it's pixels, and I'm sending from, maybe this is actually a pixel array. It gets through, and there's too much. I say, look, I can't spend my entire I don't want to fill up, let's see, what's beyond petabytes. I don't want to fill up petabytes of disk for stuff that's basically repeating. So I can do a statistical compression on them and say, look, I can set a value on what's out there, and I can set probabilities, and the worth of each event out there, so I can calculate the cost of making a mistake. Incoming missiles to aimed at a ship or a plane or something like that. You don't want to miss anything, right? It's got to be 100% if you can make it that way. All right, so to do this, if this is an operating system, basically, if there's a server running here that I can talk to. So what? Okay, so there. All right. So why am I trying to? I have there's only a certain number of tools that I have. Okay, and that anybody has. So let's put. There's so many different things here. Okay, so here's a browser. Okay, and all right. So here's a browser now. It can speak HTTP. Okay, so you can go and communicate to a server in here. It also speaks HTTP. Basically, it's an old dialect of Ethernet, but it's been broadened out. Well, I think what is that? It's just a binary package, right? And you put codes in there to indicate what's going on. If humans are involved, you really ought to keep it in stuff that can be translated and read and immediately displayed in something a human can understand. Okay. In terms of data, maybe I wouldn't put it in binary. The problem is when you put stuff in binary, the humans can't audit and work with it. So always being careful what the humans can do. You keep this in ASCII when a human is looking at it, and you can generally, it's probably just as safe to do it. Because if you got an old system and you want to read it and it's in binary, you could spend years trying to unravel it because the people didn't write down what it was. If you say, look, let's keep it in human auditable form. So this should be readable and traceable. This should be readable and traceable. This should be readable and traceable. The entire process. So, you're following data, so data, let's see, let me do a brush here. Oops. And, okay, so here's, there's some data. Okay, so here's stuff, a signal's coming in, willy-nilly to the sensor, what are electromagnetic, gravitational, acoustic, whatever, whatever data is coming in there to that analog component in the sensor, getting amplified and converted into digital form, and then read locally, processed. Some of it stored locally. I'd like to go in there and do statistical counts on all of the the intensities and the intensity transitions and region, the gradients, the spatial gradients of things, and velocities and vorticities and all kinds of basic things that you can see from whatever. So if it's a 2D array here, or part of a larger global array of sensors that makes it an array, anyway, that's about as simple as I can make it. But it comes down to right now, I'd like to get to the browser right in JavaScript, okay, because I can exchange that with anybody who has a browser. And then, frankly, I don't see any reason why your algorithm, this could run right now. Okay, you say, look, I have to write it in C because it's, that's all I got that's fast enough to talk to a device. Well, this over here, this one could run in JavaScript, right? And it could speak HTTP. So presumably you could, you don't have to go, I'm working on in Windows. Okay, that's where I live most of the time, and so I I have to be running that and have it tell the sensor what to do. I can't get the manufacturers are slow. I mean, I don't think they're going to go in and say, well, look, we'll start speaking a universal language and your browser can do. Well, what is a browser? Could be hundreds of thousands of people, involved in a complex organization, and they have their own things they want to do. We want to sell widgets, or we want to, put out some cute new things. They don't care about camera, scientific uses of cameras. That's not their job, okay? But so what you could go in there and say, look, don't put this in the browser. Give me a local, make it can be a server itself. You can write a WebSocket server inside there. I think you might be able to do an HTTP listener inside of a web page. I've never tried that, but it might be. So anyway, I guess this fits every sensor on the planet, as far as I have been able to determine. Okay, if it's one of those Star Trek, handheld tricorders for scanning humans, or the camera you send through a human, or whatever the particular thing, it all has analog interface down at the guts of it. It's like tracking electrons or electric fields or magnetic fields or gravitational fields, acoustic fields, those kinds of things. And then that is through a standard references gets converted into a series of levels, and then those levels and sequences and patterns get interpreted. Some of them are stored and read out as measurements. And then okay, let's say I go in there. If you could program every one of these, you could put in algorithms, that can do stuff in real time, and then you can get down and start squeezing out all the data that's down here at an analog state. Right now, that's all totally remote. It's so separated. If you go through the device drivers in the operating system, they don't care. They don't know anything about electrons over here, so you can't get to it. If you want to go to, anyway, so I think if all the people in the world who are working on cameras would basically think seriously about, within the context of all sensors, all operating systems, all users, the whole human species, they might have the right perspective to simplify the whole. Okay, you have to take the whole world. I tried really hard to say, oh well, here's the whole world and all humans in there, and then I tried to go in and take a single area and try to see if it could be optimized. You can't do it. It's simply impossible. The reason is the whole world is interconnected, and every single piece of it is connected to everything else. Okay, and that means even the physical environment out there. So it's just not going to be possible to say, well, we'll do our own thing. No, because you always have the rest of the world. So these are, the operating system, the browser, and then basically imagine there's the billions of people on the planet right now. They all have to deal with this. Every single person on the planet has to build this model of how things are connected and work. If they see a camera, they understand that it's looking at the real world. Every person who uses a camera has some sense that it's collecting data, that they can use. It might just be recording, but more and more people say, look, I can take that data, I can take that information, I can take that knowledge about that view of the universe through a camera and do stuff with it. So if I had a camera when I was in high school, like you guys have now, like we all have now, I would be a totally different person. I mean, I would have spent a life, doing something else. But I've had to wait 50 years to get tools even close to what I dreamed about when I was young. So, all right, let me stop here. This is too personal, probably. All right, I'll put this out there. I'm not sure what in the world's going to happen with it, but let's see what there. I'll leave the comments open on this. Write clearly if you're going to put a comment on this video. Okay, don't waste my time throwing out you-yahs and ha-has and thanks. I don't mind that. I just don't have a lot of time for it. Right? Okay. Look how much time I'm spending trying to do this. Not only have I prepared for years to try to say these kinds of things, but then I've spent this time to try to at least in a crude way communicate with you. So and frankly, okay, a lot of things. All right, this is just one. I started talking about cameras, but don't come to me and expect me to process everything. Okay, I can answer specific things, but if you go do it yourself, find everybody using your camera. If you use a particular model, make an effort to go find everyone on the planet using that. Write down their names, what organizations they work with, document and indexes. Google's not doing that. I'm sorry, they're falling down on what I consider to be their job, their social responsibility. They're doing a bad job. I'll say it that way. Okay? They could do that for you. You could say, look, this model of computer, or this model of car, or this model of whatever, and they could organize and clean it up. I mean, they're supposed to be good on AI. Okay, they're supposed to be good at finding and organizing knowledge, but they're not doing it. Okay, so anyway, so go try it yourself. At 1,000 hours is my thing. If I don't spend 1,000 hours on something, I consider I don't even know what's going on. I think I did about 22 years times 100 hours a day, 100 hours a week, 55. You can do the numbers. It takes that much human time to be able to sort. Humans are not particularly good at some things, and plowing through the whole internet is something the computer should do. Okay, but it should only. Not everybody should have to repeat that same experience. All right, let me stop here. Good luck. Thank you.